One of the main problems with graphics in Java is making text go where you want it and making it fit. Text, as you remember, is measured in points, which are fractions of an inch, and everything else is measured in pixels. Inches are fixed in size, whereas pixels vary from one monitor to the next, and this can cause some odd results. In this lesson, I want to show you a way around this problem. This example stretches and squeezes a line of text and makes it fit exactly where you want to put it. This is all stuff you've seen before, but in this case, it's applied in a slightly different way. In the constructor, we start off by creating a font. The size of the font is set to 40 points. That's a starting fixed size that we'll work with, but as you'll see, the actual size changes. Following the font object, a font render context object is constructed. The font and the font render context objects are combined with the actual string of characters to create a text layout object. It's this text layout object that will be used as the basis of everything. Take a look first at the paint method at the bottom. The first thing it does is call the create transform method to create an affine transform. I'll get to this in just a minute. The affine transform is used in the call to the get layout method to produce a shape object of the right size and position. And this shape object is then painted on the screen. So this leaves us with the creation of the affine transform, which is the job of the create transform method. I mean, if we can put the right numbers into an affine transform, it will do all the work for us. We have two different sizes to contend with, so a rectangle 2D object is created for each one. The rectangle reference trect contains the bounds of the text layout object containing the text. This object is holding the text at its original size. The wrect reference is a rectangle holding the size of the window. Now we've got the from size and the to size. These two values, x delta and y delta, contain the number of pixels the size must be increased or decreased in each of the two directions. If you examine the equations, you'll see that this is simply subtracting the values of one size from the values of the other. You'll also notice there is a 5-pixel adjustment to the size in the window width and height. This is a fudge factor to make sure the edges of the letters show clearly. Without the fudge factor, things get jammed up next to the edges of the window. Try it with and without these values and you'll see what I mean. The affine transform itself is constructed from these values. Now, I cheated just a bit and simplified things. The first thing the affine transform does is to translate the baseline from the origin to a point where the tops of all the letters can be seen. In a world where you want this thing to work for different fonts and different font sizes and ratios, you'll have to use the font metrics object to measure the ascent and move it down by that much. I just simplified things by setting it to 30, which is the ascent of what we've got. The next thing put into the affine transform is the scaling information to fit the text rectangle to the size of the window rectangle. Remember, all affine transform operations are performed in reverse order. It's a bit simplified in the code here, but these are the basic operations required to fit text. Basically, you convert the text into a shape object and then use an affine transform to make it fit wherever you want it to go. In this case, it's made to fit the whole window. And here is our stretchable text. Well, that's it for text and images. Next is motion. Beginning in the next lesson, I'm going to show you how to make graphics move in both applications and in applets.